first we're going to graph the function and then we're going to answer the questions on the bottom. So to graph this function, I'm going to take into account the domain. So notice that I have -1, 0, and 1 as my domain. So to make it easy on me, I am going to separate my graph from -1, 0, and 1. And what these lines help me is just to indicate where my graphs are. So the first graph is I want to graph it to the left of -1. So it's going to go on this last part of the graph. So it's going to be y equals to 1. So y equals to 1 is a horizontal line going to the left. It's actually going all the way across, but because I only want it to the left, I'm only going to draw it on the left. And it's a closed circle because it's also equal to -1. Between -1 and 0, so between -1 and 0, I'm going to have this line -x. So -x is a line, it's a linear line. So notice that I have an open, well, it's going to be open, but because it's closed, that the line touches it, it's closed. But on x equals to 0, I have an open circle because there's no equal sign. Okay. The next point is an actual point. When x is equal to 0, the y value is 1. So it's an actual point. It will be 0, 1. So it's an actual point. When x equals to 0, y is equal to 1. So the next one, I'm going to go from 0 to 1. So I'm going to graph it here from 0 to 1. And it's also the -x. So I'm going to continue the -x. And notice that I still have an open circle for both. The last is when x is greater than 1, also equal, so it's going to be a closed circle on 1. So that means it's going to be a horizontal line at 1. So that's what the graph would look like. So notice it's a closed circle at 1. So the next question asks, find the limit as x approaches 1 or -1 from the left. So that means I'm going to come from left to right. So as x approaches -1 from the left, I'm coming from left to right. The y value is approaching 1. Next one is the limit as x approaches -1 from the right. So now I'm coming from right to left. So as x approaches 1, -1 from the right is also approaching 1. So the C is the limit as x approaches 0 from the left. So now I'm going to approach 0 from left to right. So I'm approaching 0 from the left. The y value is going to 0. As I approach 0 from the right, the y value is also approaching 0. The next one says, find the limit as x approaches 1 from the left. So as x approaches 1 from the left, the y value is getting closer and closer to -1. As x approaches 1 from the right, so from right to left, the y value is approaching 1. G says, does f have a limit as x approaches -1, 0, 1? If so, what is it? If not, why not? Okay, so let's look at -1. So in order for the limit to exist at -1, that means that the limit from the left has to equal the limit from the right. And it does. Both limits are equal to 1. Okay. For 0, as x approaches 0 from the left, it's the same as x approaches 0 from the right. So the limit also exists at x equals to 0, because the limit as I come from the left of 0 is the same as the limit as I come from the right of 0. For 1, the limit will not exist because the limit from the left is -1, but the limit from the right would be 1. Okay, so for part H, it says, is f continuous at x equals to -1? So at x equals to -1, it would be yes, because the three things is going to occur. First of all, f of 1, or f of -1 is 1. The limit exists and is equal to 1, and the limit is equal to the point. So to show that a function is continuous at a point, you have to show those three things: that the point exists at the point, the limit exists, and the limit is equal to the point. At x equals to 0, it is not continuous because the limit as x approaches 0 is not the point. So notice that my point is actually 0, 1. They're not the same. So it's not continuous. So to show that something's not continuous, you just have to show that one of the three fails. So at x equals to 1, my function is not going to be continuous because the limit did not exist.